Hello, welcome, and thank you everyone for coming to my thesis defense presentation. My name is Behrouz, and today I'll be sharing an exciting study that explores the role of augmented reality in data-informed built environment design democratization. So I will start with introduction, then continue with background, thesis methodology and process, and at the end conclusion and future works. So this first image shows the view of my unit in January 2023, and this one is now. Do I like it? No. And did we expect this and have anyone ask us? Also no. Us, architect and urban designer, call such constructs a built environment, man-made structures such as buildings, parks, bridges, and roads that alter our surrounding to accommodate human need while considering their impact on nature. Don't worry about us, we still have good views from other perspectives. Sometimes the effect of these changes, such as this case, limit the view and sometimes they didn't, but they have wider range of effect on users' daily routine. And designers always try to consider the effect of these changes on their design proposals. But what is the role of users in this process or in this kind of changes and how they can contribute in this scenario? How could the project manager ask someone like me to share my idea about skyscraper near my unit? And how can we share our feedback regarding these design proposals? So we need to engage public who are the actual user of these changes in the built environment in design process. Why? Because this engagement ensures the developments achieve inclusive design outcome. So we ensure that we are making an inclusive design decisions. Currently, there are different ways to engage the public in the process of design. For example, this was a public engagement session to determine the new Burnaby City Hall location on a specific day for a specific period of time. These votes were held so the citizen could vote and give their feedback on sticky notes. However, as you probably guessed, there are a few limitations to this type of sessions. For example, participants' contribution was limited to the number of people passing by in that period of time, and the type of information that they could provide wasn't diverse enough. The type of data provided for the public, such as maps and forms, was technical and difficult to interpret, and the form of collecting the feedback and analyzing them, those sticky notes, was not the most effective way. So we asked, can a system with AR and presentation of non-spatial design information help to alleviate these kind of challenges? By other words, could augmented reality help tackle these challenges and make the design process of the built environment more democratic and engaging for non-expert stakeholders? These methods of public engagement involve strategies to collect input and share design information, and by this way, we can make an inclusive design decisions, pinpointing the physical and social interaction. This engagement ensures the design process can reach the goals such as inclusivity, engaging a diverse audience, overcoming communication barrier, and managing expectation and limited resources. The intersection of design, data democratization, and democratic discourse define the scope for developing systems supporting a data-informed design democratization. As a conceptual approach, we wanted to engage the stakeholders when developing design idea. We wanted to do that by informing them about the alternative solution through creating a platform for discourse around such alternatives. So we wanted to provide a platform to enable the stakeholders to share their questions, concerns, and opinion as a design democratization. In short, by democratizing data-informed design, we can engage stakeholders. We share design proposal to integrate data and forms. Consequently, data would be transparent and customizable visualization can be provided for people. Also, their participation fosters design transparency, and we aim to do this through a flexible and design and data agnostic platform for all stakeholders. So we aim to enhance public engagement through data-informed design democratization, and I developed a system that can integrate a spatial and non-spatial data visualization to engage design stakeholders. I studied if AR can make it easier for users to access and understand design proposals, and I observe how they interact with the application to see the effect of different design proposals on their surrounding, and I evaluate this AR system's effectiveness in real-world design projects. So I asked, how can design alternatives and their data be shared in an in-situ AR environment to enable and enhance stakeholders' engagement? What are the characteristics of interfaces that could be used to engage design stakeholders in an in-situ feedback sharing? And when reviewing built environment design proposals, what opportunities and challenges does an in-situ AR system exhibit in real-world scenarios? And for this aim, there has been previous tools to engage the public, and I will review a few of them that were baseline for my project. For example, Change Explorer by Wilson et al. Was a public engagement application for smartwatches, tracking the user's location and notify them when they are near any urban changes. Then we have Metropolis by Aguilar et al. It is a serious game application that allows users to decide about city development based on their preferences, like deciding blocks and type of buildings, and it was mostly for urban planning and not for individual built environments projects. Here we have DART, which was developed in Computational Design Lab. It is a web-based platform for supporting collaborative and data-driven design reviews of design alternatives. Too much design, I know, but okay. Focuses on presenting technical definitions. For the next is AR system, which is not named, so I call it LODAR, which stands for Level of Detail in Augmented Reality, and it has highlighted AR's ability to enhance understanding of urban projects through immersive experience. However, the variations in the level of detail was just limited to the geometry data. Okay, by reviewing all these tools, we gain an outline for future developments that each tool supports part of them regarding their research questions. Then methodology. This diagram shows my study process. We began with literature review to closely examine previous tools and approaches. Then through an iterative scrubbed process over 3 months, we extracted the system design and use case scenarios before running the user study, and I will take a closer look at each step in next slides. So during the literature review, we examined previous tools as I mentioned in a background, and identify a higher level of list of constraints to be considered in the app, and we also choose AR as a mean to our end. We utilized a location-based AR technology to provide users with immersive, real-time views of proposed changes in their environments. The system is called DR, which is standing for Design Democratization through AR-based Evaluation. These diagrams shows the main features of the DR system. Designers send design proposals to device through a server, then stakeholders can use GPS data and their device's camera to select, review, and compare these designs, and finally they can actively participate in discussions and share their feedback. Through the next phase of our process, we elicited the detail required for our applications through 6 sprints of expert review with a team of architects. In each iteration, we updated the design based on the collected stories and improved the implementation of our prototype. And these are the initial sketches of our system. Here are some of the examples of low-fidelity prototype encompassing the main features of application. In terms of interaction, we offer stakeholders different levels of engagement with design data. As I mentioned, DR tracks the location of its users, and it can present design proposals on demand or through in-situ notifications in an interface similar to social media application, and the design can be in any environment and any scale. Switching to the map view, the users can identify the location of new proposals around their vicinity and see the path to reaching the sites. When stakeholders arrive at the location, they receive a notification to activate their camera and switch to the AR mode to see the proposed design in their context. The 3D models integrate into the surrounding view, allowing users to explore different perspectives by walking around the proposals, and additionally, the system provides on-demand data such as charts and text, and enabling stakeholders to choose which aspect of the design they want to review and comment on, and it also allows users to easily switch between alternatives within the same context. And at the end, it offers a social media-like platform where users can actively participate by giving feedback and engaging in discussions. They can comment, upload picture, and add annotation directly within the application. From the iterations, we agreed on low-fidelity prototype, including the main feature of the application. Additionally, based on the stories, we proposed a series of use case scenarios for the usability study. Main focuses was simplifying the views and interactions for comparing design proposals, and the main challenges we faced were managing information overloaded and enhancing navigation on small screen devices. To address this, we've updated the comparison view in DR. Another important area is enhancing feedback collection section by making the interface more inclusive that allows users to express their opinion through ranking, liking, or voting instead of just writing comments. Next, it was time to code. I implemented the high-fidelity prototype of DR by integrating 4 core technologies. Google Cloud and Google Maps are used to locate and visualize the design form in situ. For precise location tracking and view identification, I incorporate Session, which is linked with AR Core, and finally I use AR Core for rendering the form data in their actual context. So project scale in built environment design can vary widely, as I mentioned earlier. For user testing, I selected this different sculpture designed to be located at the entrance of Zurich Central Mall, and using a simple and easy to understand example of design proposal helped us focus mainly on evaluating the system. This feature is similar to the previous prototype that stakeholder can choose different projects as listing option or by their location. Then, like the low-fidelity prototype, by switching to the camera, stakeholder can explore the form of each design proposals and switch between different alternatives and walk around them to explore the geometry from different perspectives. Here, they have an option to exploring the performance metrics related to each proposal. And we added a feature to comparing all performance metrics together as one integrated feature. At the end of the session, by using these features, participants can share their feedback by answering various types of questions, from ranking to open-ended ones, allowing them to express and share their idea about each design proposal. Finally, it was time to bring the app to the real world for the field test. We tested the system features with the previously decided scenario. For the user study, we aim to first evaluate the system's usability, which include observing users' behavior to see how well DR meet their needs. We recruited 20 participants randomly selected from SFU's campus entrance, and the target design data was form data and performance metrics related to those 3 sculptures that I showed earlier. So we began with study description, then continue with explaining the application's feature and ask participants to do task 1, which was interacting with the application, and then complete the task 2, which was answering surveys about the design proposals and their design of choice. Then we had post-task questionnaires that include general and detailed questions on ease of use, interpretability, and engagement of the application. Then ended the session with semi-structured interview, detailed feedback on the application's implementations. These two sessions was recorded during our user testing. In our questionnaires, we considered one general and series of more in-depth questions to each of the key constraints. One of these constraints was ease of use, which gained an impressive average score of 4.75, showcasing the app's intuitive and user-friendly interface. Well, it seems that the application was easy to use for the knowledgeable users after all. We further asked about the ease of use aspects. The least satisfaction was on the comparison of alternatives by non-spatial properties, and the highest agreement was with understanding and comparing form and spatial characteristics shows that the participants didn't have significant difficulty in reviewing proposed sculpture in situ. Next, we focus on how engaging the application was. Its engagement score of 3.9 suggests there's potential to make the application more engaging. However, we reviewed good feedback from participants like participant 3 mentioned that it was completely immersed and he didn't realize that was a fake. Then we focus on the interpretability of DR. The clarity of the presented information scored well at 4.5, indicating that users generally find the content clear, though there's scope for simplifying complex information. Okay, in conclusion, on average, the engagement score was 3.9 and it shows the need for further improvement. Ease of use, the aspect was highly rated, indicating the users find DR very easy to use. And the last one, easy to interpret, it also performed well with an average score showing that users generally find the design data clear and easy to interpret. And regarding the methods for feedback sharing, the highest performance was for the features for sharing feedback in survey format, while the lowest one was for sharing feedback as comments. Finally, DR received strong feedback, particularly for its real-time presentation of alternatives, with 95% of positive feedback, and the comparison feature also rated highly. However, the design data presentation, while useful, showed potential for improvement. DR has shown great promise for ongoing use. An average user score of 8 of 10 indicates strong potential for continued use of DR application in future by them. It does a good job of getting people involved in evaluating building designs, suggesting that adding new features could make user even happier and more engaged. Users also like how easy and clear it is to see design project both on-site and through augmented reality views, which is important for keeping them satisfied. To sum up, in this study I aim to investigate the effect of using a location-based augmented reality in data-driven decision-making through swing data democratization. We did this because we observed this gap between the designers and public seeking design process transparency and understandability, and I reached that aim by developing DR that I presented to you through this presentation. In our study, we identified challenges with AR technology such as the need for precise geolocationalized and high-performance hardware, which can limit accessibility. Small screen size and processing limits are the other limitations of using smartphones. We also noticed that users struggle with integrating different types of data. Further designs should consider more intuitive display options like superimpose or side-by-side views to enhance understanding and interactions. We're looking for three major areas for development. First is explore integrating AI-driven analytics to automate feedback collection and analysis to streamline decision-making process. Second is expand AR functionalities to support more complex urban environments and accommodate a wider range of user scenarios. And at the end, conduct long-term studies to evaluate the impact of AR technology on public engagement and urban planning, ensuring sustainable development. Thank you so much for listening to my presentation.